I would like to address just a few housekeeping items. If you haven't already, please take a moment to mute yourself. This presentation will run approximately 45 minutes, followed by a 15-minute question and answer session. During the presentation, if you have any questions, please feel free to place them in the chat session. I do believe at the bottom of somewhere on your screen, there should be a toolbar that does have a chat bubble. If by chance you do need to leave early, don't worry, we'll be able to provide you with a recording of the webinar to review at your convenience. Certificates of attendance will be sent to all participants who have completed this webinar. And again, at this moment, if you haven't had a chance to do so, please mute yourself. So in this webinar, we will be addressing a few things. The significance of air quality inside your building and the impact that it has on energy consumption, production costs, electrostatic discharge, dust and pollution, wood moisture, and human health. The EPA estimates that poor indoor air quality affects 33 to 50% of commercial buildings in the United States. Some takeaways that we expect you to learn is, what does good indoor air quality mean? How can you test for good indoor air quality? What tools measure air quality, temperature, and humidity levels, and how you can reduce energy costs, improve processes, and control dry air, and what products can be used to improve indoor air quality and increase profits. I would like to take a moment to introduce our two speakers. The first is Eric Dustin. Eric Dustin is the sales director in the United States for Airthings, a global technology company, producer of award-winning radon and indoor air quality monitors. Airthings is on a mission to empower people around the world to breathe better through simple, affordable, and accurate technology solutions. Eric, welcome to the webinar.
Thank you so much, Erica. It's really exciting to be here and be a part of this, and looking forward to spending some time with everyone.
And our second speaker will be Richard Williams. Richard Williams is the regional sales manager of Condair, a leading manufacturer and provider of complete solutions in the area of humidification and evaporative cooling, creating the ideal indoor climate while keeping energy consumption low and reducing the impact on the environment. Rick, welcome to the webinar.
Thank you, Erica. I'm looking forward to being here today and providing the information to everyone in attendance, and ready to get this thing kicked off.
Okay, so how did we partner? Airthings and Condair's webinar partnership came together from Dr. Taylor Global Petition 40to60rh.com. If you haven't already seen the petition yet, Dr. Taylor is advocating to the World Health Organization that they recommend minimum indoor humidity levels for commercial buildings. Airthings saw the petition and wanted to be involved as a supporting partner. Condair is also a partner, and it was a natural fit for both Airthings and Condair to work together because they both share the same passion for improving indoor air quality. If you haven't signed the petition yet, please show your support at 40to60rh.com. And at this moment, I'm going to turn the presentation over to Eric Dustin. Okay, and
Excellent. Thank you so much, Erica, again. And with that, I think we'll dive right into it. We'll take a quick look at an agenda. And sorry about this. There we are. It clicked over. So real quick, I'll give everyone a brief introduction to Airthings and who we are, and then we'll dive right into indoor air quality, why we should measure it, why we should really be paying attention to it, both from an occupant health standpoint and also how that really ties into the building health. We'll take a little look at that, what we should be looking out for measuring, and then move right into some applications and of course how that ties into Condair and humidification and really, again, that whole building health and occupant health. It is not moving for me, sorry about that. All right, so we'll dive right in. So Airthings was founded in 2008, actually. It's a pretty interesting story. Our founders worked for CERN and really took, they had a dream of having more of an impact. And that led them to creating Airthings and starting off at Corentium at the time, but really moving towards and creating the first ever battery operated digital radon monitoring solution. And from there, radon being that really invisible gas and a concern both residential and commercial and what we're breathing in on a daily basis, really led us to develop and move into kind of an all-encompassing indoor air quality solution and monitoring provider. Now, in that really short amount of time, we've actually grown to over 100 employees in 20 different countries around the world. And it's really just been an exciting time for me to be a part of this community and this organization and help bring some awareness around what we're trying to do. All right, so with that, we will dive into why IAQ, or indoor air quality. All right, so this is one of the most fascinating statistics to me, I think, when I was really getting into indoor air quality and how much we should pay attention to it, is because we spend on average 90% of our time indoors. There was a fascinating study, this came out in the 90s, that I believe it was about 86% at the time, and now adapting it and moving forward with how much time we spend indoors now, whether we're in our car, in our homes, in a commercial building. It really is pretty amazing and fascinating how much time we're spending indoors, and that really is, that's that air we're breathing, and how effectively can we do it and manage that, and in that, again, that commercial space or in that more residential space. So now that I think we identified where we spend way too much time personally, let's look at what that means to us and what potentially negative or positive impacts it really could have. And the transitions do not seem to be working, Erica.
Okay, let's see.
Apologize for this. All right, there we are. So, and we're just going to hit on a few of these things. Again, I want to be conscious of the time we have. So a few things that are really important to us. We have everything from, say, loss of concentration. If we're in maybe a K through 12 school or higher education, or maybe we're, back to the days when we were all in the office, we're in a meeting room for a very long time, and people are starting to drift off, lose concentration. It's not necessarily because you ate too large of a lunch. It could very much be from your air quality or elevated CO2, and we'll hit on that a little bit. What about asthma and COPD and other triggers that also contribute, are a direct result of things in the air that we're breathing? Certainly cancer with radon, there's depression, low productivity, and I think one of the most things prominent on everybody's mind today is the spread of infectious disease. And there's a number of contributing factors we can look at and monitor, and not only look at it, but also address it if there is a problem, that are going to significantly reduce the potential for infectious disease to spread. And I think that's, again, leading to the environment today, whether it is the CO2 or certainly very importantly, and we'll talk a little bit about this, is humidification. How can we limit that or reduce the potential for that transmission through our indoor air quality? All right, next slide. All right, excellent. So just we'll go through some relatively high level on this slide. What are some of those parameters? Again, I alluded to some of them, but CO2. Now, CO2 is going to be very important for that cognitive performance, making sure that we have proper ventilation. If I relate it to the ASHRAE standards, I believe historically it has been 750 parts per million over your outside air. And of course, it is because your outside air fluctuates where you are, but it really is a powerful indication of how well you are turning over that building. And again, one of the trends we'll cover in a little bit here is how ASHRAE's recommendations have changed over the past few months, specifically to CO2 and a few other of these parameters. Another really important one is TVOCs, or those total volatile organic compounds. Those are interesting because it can be anything from paints. It could be depending on what chemicals you're using to clean the facilities. So we really want to look at them. It could also be, there's quite a few research articles that have related TVOCs to the gestation period of certain fungals or bacteria or even viral infections that are actually off-gas TVOCs. So certainly if you have elevated TVOCs in your space or TVOCs, you want to take a look at that and look at potential solutions on how to reduce those or eliminate it ideally. And another very important measurement we hear a lot about is going to be particulate. So I'll cover that off in a little bit here and what those meanings with that PM1, PM2.5, and 10 really are and how they relate to us. Of course, we have our traditional temperature, and very important is humidity. I think humidity is, one of the most critical things we can look at. It has an impact not only, again, on the spread of viral, it has an impact on how effective our equipment, what the life expectancy of equipment can be. We can extend it. Certain process applications, humidity can be one of the most critical functions of how well that process is completed and how efficient or effective it is. So certainly something we want to look at. And even as simple as pressure, it can be very much used to tell how your building is performing, how well it's moving air through those different zones, which is again going to be critical to making sure that we provide a good environment for the people in that space. And finally, radon. Radon I think is something we really try and educate people about, because generally speaking, what I've experienced is radon has always been associated in the US with a home transaction. You're buying or you're selling your home and you're looking at a home inspection, and it's not generally associated with commercial space. But the problem is that it is absolutely in that space. And again, if say our kids are at school for 8 hours a day, or even us, if we're in that commercial setting and there is radon gas, I think it's something we should really be aware of. And it is a relatively, I'll say relatively easy fix. You can really mitigate it through ventilation processes and bringing in, again, fresh air. So let's look at some of them a little more in depth, and again, the potential negative or positive impact. So we'll start just real quick with CO2. This is actually from a study done in Berkeley Lab, and you can see the white bubbles are essentially going to be what I would roughly outdoor air. Again, depending on where you are, but pretty close to outdoor air. So that's really the ideal environment that we want to be in. And you can see simply the blue dots are 1,000 parts per million CO2, and it does not take a lot to get there. And of course, the black dots are all the way up to 2,500 parts per million, which unfortunately is not that uncommon, especially in a meeting room where we'll see this all the time, or K through 12 schools, really high occupied space where you might not have the best ventilation or demand-based ventilation. You can see, I know I've been in those meeting rooms sometimes for far too long, too many hours, the doors closed, and next thing you know, people are falling asleep. They don't seem to be necessarily as productive. Well, look at our basic activity, look at our initiative is certainly significantly impacted, our task orientation. So all of these, really our cognitive performance, our ability to even perform in that environment is significantly inhibited just by CO2. All right, next slide. So we'll dive a little in particulate. So I wanted to give everybody kind of a, I love pictures, right? It gives me a better idea of what exactly I'm talking about, rather than just PM 1.0 or 2.5, which is that particulate matter. So what we've got over on the right is simply a human hair. You can see the blue bubbles are the PM10, the pink ones are the 2.5, and I could not even really get the PM 1.0 on here because they are that small. So another way, I love examples, right? So when I look, we've all experienced that, where you look at the sun is coming through a window and you see all the nasty dust or particulate floating in the air. That really is, to some extent, what this particulate is. And why that is so important is, again, there's many studies that this is asthma triggers, this is COPD historically, this is your filter effectiveness. Certainly some processes are absolutely dependent on being in that clean environment. So it really depends on the application. And again, if I relate it to today, there's been some pretty significant studies that have shown by filtration and removing that particulate matter, and there's a number of technologies that are very effective at reducing that particulate. We've seen up to a 500% reduction in viral spread in trace contact. So again, significant ways to improve our indoor air quality and give people that confidence to get back in our space. I think that's one of the main goals, regardless of where we are, is to really get the workforce back in the buildings, using them, and building that team and that cohesiveness back in that space. Next, please. So, and of course, there is relative humidity. And again, I mentioned that this had a significant impact on the potential for viral spread amongst other things. And you can see on this graph, again, viruses, there's respiratory infection, and it impacts us in a number of ways in addition to the equipment, which I will leave more of that to Rick also, as he is certainly an expert on that. And so just an example, at 23% humidity, over 70% of flu virus particles are removed essentially, sorry. So at 43%, 14% of them are still transmissible. So we have an 86% reduction. So incredibly effective. And again, you can look at these from a respiratory infection. Relative humidity is also going to impact our body's ability to fight off infection. So it really is critical. And let's go to the next. So, and as I talked about too, again, this really, we're tying the health of the occupants to the health of the building. So all of these things we've talked about, or I've alluded to, is not just people. CO2 is, again, how productive and how efficient is your HVAC system? What is your air changeover rates? Can we possibly look at demand-based ventilation? Same thing with relative humidity. Do we need total space humidity, or are there specific zones? So it really is, you can look at it from both a people standpoint and an occupant standpoint, or also an energy effectiveness standpoint. And again, that health of that building and the life expectancy of equipment. Let's move to the next one, please. So here's just one example of, I'll say, the health of the building. And again, it really ties into both. So with this monitoring solution, what you see right here, we can tell exactly when that ventilation schedule kind of kicks on the system and when it turns it off. So traditionally, we have our controls contractor going out and commissioning our building. Now, at that time, it's not necessarily an occupied space yet. So we have to make a few assumptions on when it's going to be occupied. We have to make a few assumptions on how long it will take that building to really get to the conditions, to satisfy the conditions where it's in that positive environment. And one of the problems with this is, after commissioning, that building load profile and the way that building is used is going to change very much over time. So without a monitoring solution, you have no idea what it's going to look like a year from now, much less 5 or 10 years. So in this quick building example, we were able to identify 18 hours of overventilation because it was very effective at getting to the proper conditions. And actually what we've done here is overlaid it with occupancy. So, and we still left a little bit of room just in case people, say, came into the office early or left late at night also. And Friday, we identified that people were actually staying later than anticipated. So long story short, we were actually able to optimize this ventilation schedule for 15 hours reduced ventilation a week. So again, that's not only the occupant health side of air quality, but it's also now significantly more energy efficient. We can build in a return on investment. And then also, it's not even just the energy, it's going to be the effectiveness and the lifetime of that equipment and less run hours and maintenance. Let's go to the next one. So also here's another way to look at it is simple, really pressurization is one of the most important things we can look at. And this kind of goes also to the way that building load is going to change. So we have a multiple number of factors that really contribute to how that building behaves or performs over time. The stack effect is just going to be our kind of normal transitions, the way gas is going to move throughout that building. Wind is going to have a significant impact on it. And then also, of course, our mechanical systems. So really, again, without monitoring this, and you can imagine wind is obviously changing every day, the number of people in our building are certainly changing. You know, occupancy 12 months ago compared to occupancy today is probably significantly different in most of the buildings out there. So being able to look at that, the pressurization, the airflow, and then also even potentially account for leakage within that building, there's significant energy savings, and it also helps us build in kind of stability within that building system and able to maintain appropriate temperatures and humidity. All right, so I've hit on a few of these too, but just to touch more on base trends in IAQ, I did mention ASHRAE, and specifically they just released a reopening guidance for schools and universities, and this is a direct quote. So trend and monitor as much information as possible in each space, such as temperature, humidity, CO2 concentration, zone population, et cetera. And that's because really all of these factors are going to contribute to the health of our people. And really what I like to call it is restoring that occupant confidence, because we do have some uncertainty and some unknowns. So by monitoring IAQ and having these strategies in place, you really give people kind of some insight into that and again, comfort to be able to get them back in that building. And to the CO2, I had mentioned it was 750 parts per million above outside air. Which is generally puts around 1,300 parts per million. They have changed that where it's now that 800 to 1,000 parts per million CO2. And again, that's just a great indication of how much outside air we are using and what really is the saturation of that air in that space. Excellent. So, and here's just a few ideas too, or things that we can do with this data that I think take us really beyond just CO2 and temperature. And what we've done, we call them virtual sensors, and it's algorithms and it's inferences or it's insights that we can gain by looking at this data and what we know about air quality. For example, on the top left, we have by temperature, CO2, and time. Of course, there are a few other parameters, TVOCs, et cetera, but you can give an algorithm and get a very good idea of what is the occupancy within that space. And it's a very non-invasive way of doing it, rather than having camera counting or occupancy at the asset level, which can be incredibly powerful in many installations or many applications. But this is another way to get occupancy and again, make sure that we're not overcrowded. Again, that's obviously a pretty major concern nowadays. Another example is mold risk. So while these indoor air quality sensors might not be able to specifically detect mold spores, if we have temperature and humidity and time, we can identify whether that environment is conducive to mold growth. And personally, I think that's actually a little more powerful. And I say that because once we have mold in the building, or discolorations. I know you generally don't want to say mold in a space. So if you have discoloration and you're able to detect that in the environment, well, it's a bit too late. We already have a problem now, and you have to get a mitigation plan and potentially shut down parts of the building. Whereas if you can identify that before mold is actually capable of growing, you really have a leg up and you can prevent that from ever being a problem. And again, you know, we talk about humidification. I think it's so important that we maintain that 40 to 60 RH for our occupant health, but we don't want to do it if we're going to have mold. So again, I think insights like this are critical where we can really look at all of it and from again, minimizing viral transmission while ensuring we don't have other elevated risks in that space. And, you know, just thinking along these lines, not necessarily done yet, but we know humidity impacts viral transmission. We know temperature impacts viral transmission. We know this particulate does. We know the occupancy does. And there may vary, I'm sure there are many other circumstances or parameters, so to speak, that go into viral transmission. But is there a way, you know, as we advance through technologies and our knowledge and our indoor air quality and our awareness, is there a way to identify how risky is your environment to viral spread? And again, that goes back to getting people back in that safe environment and back in that space. Go to the next, please. All right, so real quick, we're gonna go through some just applications. We'll go to the next one. So specific to the Airthings solution, so really taking in all of these kind of core functions and things we've just discussed, we have come up with a solution that can improve that both the energy efficiency, the health of the building, and of course the health of those occupants. So generally, I've done a few installations, quite a few installations at this point, and I say this because it's incredibly easy to install and set up. I am not the most technically savvy person. But even myself, I usually give myself 3 to 5 minutes to install a sensor. It really is that easy. They are all wireless battery operated devices, simply mounted on the wall with double-sided tape or a single screw. And all of our sensors, I say, are multi-sensors. So we have those 7 physical sensors. And then in addition to that, we are also running a lot of those algorithms and providing insights, which is constantly evolving. I know a year ago, we did not have a mold risk at Airthings, whereas recently we've launched that. And so we are continuing to grow and to develop and constantly adding value to that solution. And also, again, it's self-calibrating too, so very low maintenance, easy to install, get up and running, and start providing those insights for the people and get us back at work. So here's just a quick snapshot of the Wave Plus. I'll say our flagship sensor at the time being, or right now, it has radon, TVOC, CO2, humidity, temp, pressure, and light. Light is actually a critical function of our occupancy sensor too. So it really is kind of our all-encompassing right now. We actually, fantastic, we were awarded one of the Time Best 100 Inventions in 2019. So really proud of that. And again, it's looking at all these, you know, some of these main parameters of IAQ that we've talked about. Next slide. So just the Wave Mini for Business, another one of our sensors in the portfolio. We have removed radon and CO2 in this sensor. Again, it really depends on the application. If we don't have a heavily occupied space, CO2 might not be as important. Certainly if it's an elevated space on maybe the 15th floor of a building, we might be able to get away with without that radon sensor. Still really like to see that Wave Plus, but this absolutely has quite a number of applications too. And I'm going to go relatively quick too. I know we had a few minutes getting ready there with the clicking. And this is just our hub. So all of these sensors send the data to here, which again then sends it to the cloud. So it is completely a wireless cloud-based solution. Let's go to the next, please. And just to give a general idea, this is kind of what I covered. They communicate through the smart link to the hub up to AWS, and from here is really where we populate the dashboard. I'll give you a few examples of that and the capabilities, but then also I think critical to this is we are continuously asked to integrate it, whether it is a Modbus or BACnet. We don't necessarily need to do that, and we don't need to run the wires because we're going to leverage that API, but we still get that same functionality, and we're able to integrate with the building automation system or management system. Next slide. Here's a quick snapshot kind of our dashboard. It is completely customizable, but again, I mentioned we can set up the webhooks and the REST API. We have actually had people that are doing control based off of the data we provide, the analytics team, the smart notifications, occupancy and floor plan. Again, I want to show a quick example of that, and then we're going to hand it off to Rick, and he's going to educate us a lot more about humidification and some of those applications. If we could go to the next one. And here we go. So this is just, again, a small portion of what we have in our dashboard. This is actually humidification. again, I think it's one of the most critical parameters we can look at, both from our machine life expectancy, occupant health, and it's a relatively easy fix, and the benefits are endless. So this is an example. We can actually upload schematics into the building management system, where again, it's a little cleaner. You can view it, not an interactive demo, but you'd be able to click on each one of those sensors and get those parameters and hopefully find out what's going on with that room. Or certainly if you see a 23% humidity, you probably want to get a in-room humidification system. So again, I just thank you so much, everybody. This has really been great, and hopefully you learned something. With that, we're going to move on to Rick, and he can talk more about direct room humidification systems. Thank you.
All right, thank you, Eric. Appreciate you taking the time to discuss how Airthings helps measure and improve indoor air quality. And as Eric said, one of the key components is humidification. Since this is a commercial-focused webinar, I want to kind of keep my presentation focused on operational issues in a commercial space, how it helps your process, as well as the facilities that your operations are in. So I think I might be having the same issues. Oh, okay. Here, we've got a quick overview of the direct room humidification system, some things you need to know. If you're already familiar with a traditional isothermal humidification system, this is a completely different technology, but it can be used in the same applications. Obviously, there are reasons why we would use a direct room humidification. A lot of it has to do with size of the facility. Again, looking at commercial space, we're generally dealing with larger manufacturing facilities, production facilities, those type of operations where having an energy efficient system that provides the humidification you need for the process, as well as the health of the people in the space while helping to improve indoor air quality is critical. I mentioned energy efficient, low cost. Some of our systems do qualify for incentives from utility districts. Also, the new CARES Act in the U.S. offers tax rebates for the system. And again, since we're in a commercial space, bottom line profitability is always in the back of someone's mind. So I like to touch on those. Also, it is a very versatile system. These are all custom designed for each specific space. So it's not, hey, pull it out of a box, throw it in the space and let it rip. It's something that we actually take the time to work through design for the specific facility. Also, it is very ultra hygienic, and I'll talk more about that later. We use different levels of treated water and different systems to provide that high level of hygiene, which is important for the personnel who are actually in the space, whether it's out on the production or manufacturing floor or in the office space within the building. Let's see, can you go to the next, please? Thank you. Just a quick snapshot of what a system would look like. On the left, the pump skid for the system is generally out of sight, out of mind in the mechanical room. And then we have high pressure flex hoses that are run out to distribution heads that are typically mounted on the ceiling, sometimes on the wall in the space, and are producing an atomized mist directly into the space. Some of the advantages of this system is they're great for retrofits. There is no cutting sheet metal or cutting into ducts. This is all done without the need for that type of installation. Also, it is very flexible, so we can go from very small loads up to several thousand pounds an hour, which is something you typically can't do with other technologies that the Condair provides. Next, there we go. Next, talk just some applications from some of the markets where the direct room systems are most applicable and where we see the biggest need and understanding from the end user, from the customer who understands why they need this. Again, what they're looking for is to maintain a fairly tight humidity level for their process, obviously needing treated water in the electronic side because they don't want any type of minerals, getting out into the environment. So with using a DI water, eliminates the minerals, which prevents dusting. Also, ESD protection is a huge application for this. There's been some reports done within the electronics industry that talks up to 1/3 of damaged boards and components are directly attributable to ESD. And when we have the correct level of humidity, which turns out to be between 40 and 60% RH, it drastically reduces the ESD problems that you can experience in the facility. Then we also look at kind of the dual benefit of the system. While it's helping your process in the space, it's also impacting the people in the environment. Kind of back to what Eric had to say about how to measure and implement changes in your indoor air quality. Humidity is critical for that. Next, please. Printing, very similar. Obviously, you see a little higher humidity level. Again, I'd like to just touch on some of the benefits here, again, because for the commercial side, we want to focus on how we're going to help you improve your operations, reduce downtime, improve your quality. And here on the printing side, the humidity is needed to maintain the integrity of the material that's running through the machines. As soon as that material gets even slightly out of spec, you can run into issues with the machine going down, poor quality, have a lot of waste and scrap and rework that needs to be done. Next, please. And it's very similar with packaging. This is another huge industry for humidification. Very similar requirements. Again, maintaining the integrity of the material that's running through the machines. So next, please. Woodworking, same thing. We worked with some woodworking manufacturers. One of the problems they have is if it gets too dry, the material they buy starts to split and crack. It turns into a significant waste and scrap problem for them. Also, another interesting application on this side is if the humidity isn't maintained correctly, the wood can actually lose moisture. And a lot of these companies will buy wood product by weight. So if they aren't maintaining the right moisture in the wood, then they're actually losing profits from just pure evaporation. So next, please. Here, just one interesting piece here on museums. A lot of times people don't think about it. I've done some work with the Seattle Museum of Flight. They had an interesting mandate that they have to maintain all their artifacts and their exhibit pieces, not for the next 20 or 30 years, but for the next 200 years. And they understand how important it is to maintaining the right indoor air quality level, with humidity being a huge portion of that, so that those pieces that they have on display and in their archives will be ready for use over the next several decades. Next, please. And on textiles, just real quick on this one, again, if it is out of range, you can see a very high humidity requirement for textiles. You get a high ESD buildup, electrostatic discharge, which causes problems with machinery, or the material will break, which obviously causes shutdowns and additional repair and lost time. So next, please. And just a quick rundown of some of the other applications. Again, if you can think of an application where you need humidification, whether it's just for your process or part of overall indoor air quality, the direct room system can find a fit in there. And just a quick couple of comments on human health. We've done a lot of webinars, and there's a lot of information about it out there. Eric had alluded to this earlier. It's interesting, from a process control, most processes, the sweet spot for humidification is 40 to 60%. And if you notice, it's the same for human health, that 40 to 60% range. So while you're improving your process, your quality control, you're also looking after the people that are working in the environment. So kind of get a twofer. on this application here. And then here, you saw this before on human health. This is the Sterling chart, which some of you may be familiar with. Just real quick on that, there in the middle is where not many bad things happen. On the outside is where you can get into a lot of issues and a lot of problems. Again, not going to get into a lot of detail. There's a lot of other information out on our website that discusses this as well, or at the 40 to 60% RH website. So next, please. Well, with the adiabatic concepts, sometimes people really aren't familiar with what that means. It's just simply a phase change from liquid to gas. We're moving water to vapor. Here, the issue with steam humidifiers, which is what most people are very familiar with, is that you're boiling the water to achieve that phase change. And that gets very expensive, especially if you have a load requirement of hundreds or thousands of pounds. With the adiabatic humidification system, you're not boiling any water. You're simply taking supply water and atomizing it directly into space. So very little energy is required. So a much cheaper way of handling humidification. Next, please. Here, just a quick shot, which kind of puts it in perspective on the left. What we're looking at here is if you take a typical facility, a manufacturing facility, and that needs humidification on the left, this is what it would cost, about $130,000 to run an electric steam humidification system. And if you look at the third from the right, or the first one that says the rebate arrow, that's a high pressure system. So you look at an annual cost of about $420. Again, significant savings, which is one of the benefits from an operational perspective of the direct humidification system. Next, please. Again, very low cost, operating cost, because you don't need much power to operate the system. These do qualify for energy incentive programs from local utility districts. We have seen customers that have gone through the process receive rebates as far as an actual rebate check, not, well, somewhere down the road, we're going to send you some money, dripping in every month. A single rebate check of between 25 and 50% of the project cost. Also, another side benefit of the system, it does provide the adiabatic cooling, which helps take the load off facility HVAC systems. So they're not running as often, which drives down the cost of your utility bills, which again, then just float additional profit down to the bottom line. Next, please. Here, the CARES Act, as I mentioned earlier, this is a new program that's part of the coronavirus economic stimulus package that was put together. It's nice because they allow you to deduct 100% of a project cost over a single year. Typically capital projects, which this usually falls under, are expensed over 20, 25 plus years. And these are all part of tax credits that come right back to the company. And a lot of this information as far as the tax credits can be gathered from your company's accounting or finance people. And you can see pretty much anything that's not a residential property applies for this. And there's a lot of different pieces of equipment and systems that will apply for it. And humidifiers fall under the other HVAC devices. Next, please. I know we're kind of getting to the end, so I'll try and go through these a little quicker. Next. Here, just a quick overview here on the right is what the system looks like. There's the pump skid, and then we have different distribution heads. Again, these are all custom designed for each facility. Next, please. And here's what one of the distribution heads look like when it's running in space. It actually provides the atomized water in a 360-degree ring around the distribution head. And here's one that's designed for lower ceiling applications where you just don't have the height. Again, this one, you can see kind of the atomized water coming out of the distribution head. And then the next one we have is, you can kind of see it in the middle of the image. This is for extremely high ceiling applications where or a absorption distance is not a big concern. So just another way of providing you need on a large scale. Next. Here, for hygiene options, a clean in place, which provides a food grade disinfectant that is introduced into the system. It's an FDA approved process. Also, we do provide the treated water, and then each system does have at least one, in some cases, we provided 2 UV lights for sterilization of the water running through it. Next, please. And some of the services that Condair provides as part of the equipment is we have factory install technicians. They're not factory trained. They're actually Condair employees that will come out. That's all they do, handle the install, startup, and commissioning of the system. It's almost a turnkey solution. There's a little bit of electrical work that needs to be done, or our techs are not qualified electricians. And we also offer a bacteria testing that's done on site because the water that we're using is coming out from the supply. Again, it's not being turned into clean steam like you would with an isothermal system. So we want to make sure there's no issues with any bacteria growing in the water. That can be done. Again, just really servicing the entire system from start to finish. Next. And then just a quick overview of the water hygiene. Talked a little bit about the clean steam coming out of isothermal. On the adiabatic, again, we look at the UV light to help with any bacteria in the line. Silver ion dosing, that's been a tried and true technology in hospitals for a long time. So we use that as well. Also, we provide RO water treatment to make sure that we're taking any contaminants out of the water as possible. And then again, talked about the bacteria testing already. Next, please. And just some information from ASHRAE. One of the biggest concerns with water is Legionella that can potentially grow in there. So ASHRAE provides guidance on how to help prevent the spread of Legionella in the water. So it just gives a couple reference points for that. Next, please. Yep, and just kind of wrapping things up. Again, any application where you use traditional humidification, direct room system can be used as well. Much more energy efficient, long-term operating costs significantly lower than almost all other humidification technologies, and with as many options and the custom design, we can put it pretty much anywhere it needs to go. And I think that's next, please. Oh, and so now we'll turn it back over to Erica for a Q&A, and then we'll wrap it up after that.
Okay, so before we move on to the question and answer session, I just want to let you know that we will have a few lucky winners in our audience. As registrants to the webinar, you are eligible to win an Airthings Wave Plus or a mini Condair hygrometer. The Airthings Wave Plus is an air quality monitor working with a free app, and it can be used in every room of your home to monitor your air quality level, including radon, CO2, VOC, pressure, humidity, and temperature. The Condair mini hygrometer is a hygrometer. It's approximately 2 inches tall, and it can be placed in any room in your cubicle, on your desk. And this is also to monitor temperature and RH levels in the area. All names will be thrown into a drawing. 1 lucky winner will receive the Airthings Wave Plus, and 10 lucky winners will receive the Condair mini hygrometer. So good luck. And now we will turn this over to the Q&A session. So if anybody has any questions, please put it in the chat session now. Okay, so I do have one for Rick. Why do I need to use treated water with direct room humidifiers?
Thanks, Erica, and that's a great question. With the direct room humidifier, we're taking supply water. So whatever's coming into your facility, that's what we're using for the source. And we want to make sure that we treat it so that we're looking after two aspects. One, the health of the people in the space, and then also to help with your process control. One of the biggest things we see from a process control side is the prevention of dusting in the environment. And dusting is simply just minerals in the water that if they're not removed will settle out and form like basically a white sheen over everything in the facility. So by using whether it's the RO and DI or just the RO, we're able to eliminate that while enhancing the indoor air quality for the personnel that are working in the space.
Great. I have one for Eric. If we are going to monitor IAQ, where do you place the sensors?
Oh, that's a great question. Thank you. So really, we like to look at the space, but there's a few general recommendations. So our sensors, if it is open space, I'll say we'll be able to monitor approximately 2,500 square feet of space. So what we really want to do is get them in the breathing zone. So approximately 5 feet, for example. Of course, a little bit of flexibility with that, but really we're focusing on the air that people are breathing. And then we want to avoid open windows, fresh air, really where fresh air is coming in. So if the ventilation at that input, because we want good readings of what that air mixture is and again, what we're breathing. So really trying to get it in a high use space, I'd say.
Okay, another one for Eric. If I have multiple buildings I want to monitor, will I need different dashboards?
Another great example. So the way we've set up our system is it really is advantageous for multiple locations. So I mentioned how all of these sensors send to a hub and a hub sends it up to a cloud. So if you have multiple buildings in your portfolio, we can actually integrate all of those buildings to a single dashboard. So you don't have to log in and go to different sites throughout the course. You can really, again, customize that dashboard where you'll be able to see all of your locations and any notifications that come with that.
Okay. Rick, what is the reason for short absorption distance from the distribution head?
Another good question. One of the concerns that people will generally have with a direct humidification system is, they see the water being atomized directly into space, they worry about dripping and water falling out over, whether it's machinery or over people, over walkways. So when we have the distribution heads with a short absorption distance, we actually put a little fan in underneath the spray area. So that does two things. One, that helps keep the atomized water suspended for an extra few seconds, and also spreads it out so that it will absorb into the environment over a larger space, and it's done quicker. And that's one of the technologies that we use to help prevent drips coming from the system.
Okay, another one for Rick. How do I get a rebate for the system?
Yeah, that's good to know, especially when we're talking, that's real money coming back into the company's pockets and flowing right down to the bottom line. This is something that many local utility districts around the country do provide rebates for pulling KW off the grid or potentially saving KW. The local utility districts, they're into helping people save KW. And it's something that you would need to get with the local utility district to find what their process is. We also do have people within Condair that can help with that. The companies that I've helped work through the process, it's generally forms that the local utility district has that you need to complete, send it into them. Sometimes they'll come out and just look at your system to make sure that you actually put it in place and that it's installed and running. A couple of times I've heard they've come back out to do like meter checks to say, yeah, well, you really are saving the money, and then able to issue you a rebate check. But it's nothing that I've heard it's fallen into the too hard to do category. It's just a process that
Okay. Eric, what are some of the chemicals the TVOC sensor reads?
Another good one. So really that's going to be, there's a wide number of things. It really is hard to pinpoint specifics, but some examples are going to be, I mentioned, depending on the cleaning supplies that you use. We've had many where we have a sensor in a, say, cleaning closet, for example. It's not uncommon to have incredibly elevated TVOCs, and then we're actually able to ideally maintain a lower pressure in that specific zone or room, so it's not going to other zones. But it could also be paint. It could be different construction. It's, you know, TVOCs are everything from that new car smell. Sometimes that isn't necessarily bothersome to if you install new carpeting. You could see that also at TVOCs, for example. And again, all the way up towards, you know, ones that you don't necessarily smell, but potential off-gassing from bacterial growth even. So there really is a wide number of things that are covered in that those TVOCs.
Okay, and it looks like we got one more question for you, Rick. How is each zone controlled?
with the direct humidification system, again, it is designed to handle a very large space, you know, areas that can be hundreds of thousands of square feet. So on the pump skid, or kind of where all the magic happens, is a PLC controller. And from there, we run a humidistat out into each space or each zone so that we're able to get real-time feedback on the humidification level in the room. And then that information is continuously sent back to the PLC controller. And then when there is a call for demand, because say the humidification level has dropped or starting to drop, then the system automatically will spray water or atomize water into the zone where the call for demand is coming from. And the system can be zoned from as simple as a single zone to systems that we've done have been 40 zones. So again, it's a very flexible, very customizable system that can be set up for multiple zones.
Great. Okay, well, thank you. So as we're coming to a close, I do want to say thank you for everybody participating in our webinar today. If you do have additional questions that have not been addressed here during the session, please don't hesitate to reach out to either Rick or to Eric for more information. This information, like I said, we will be sending a recorded webinar, so their contact information, while it's still up on the screen now, will also be provided in the recorded webinar. So thank you, thank you. I really do appreciate everybody joining us today. Okay, and I'm going to stop the recording now. So thank you again.